_freebsd. Make sure you have that pulled down and started up for Mike's part, which is coming up next. There's a new competition in April 5th to 6th in Fargo at the Midwest Instruction and Computing Symposium. They're holding a bunch of different competitions. You might have seen this in Slack this past week. There's a robotics competition, a programming competition, and a cybersecurity competition, as well as a career fair. We're interested in the cybersecurity competition. Basically, the description of the actual competition is still pretty vague. It seems like it's going to be similar to Cyber Conquest, for those of you who have participated in that. It's basically going to be attack and defense, but not at the same time. So the way the rules look right now is that there'll be different rounds. It seems like you'll go head-to-head against one other team. You'll do an attack portion where you'll be attacking the other team and they'll be defending, and then another part where you'll be defending and the other team will be attacking you. We can put together a team of 10, so 5 defenders, 5 attackers. There's going to be a little bit of overlap because for each round we can have a team of 6. So we're going to need like at least 1 or 2 people who can do both. So yeah, we're going to start putting together a team with that, with OffSec. If you're interested in doing either portion, you can sign up at that link, and we'll have a team put together at some point in the next month or two, month and a half. Anybody have any questions about it? Okay. The link is in Slack if you don't have it.
So we're going to start with all the FreeBSD stuff. So hopefully Eric magically gave it to you. If not, hopefully you have it pulled down and powered on by now. Ask here a second. Not receiving output yet?
No, it was there, but it went away.
Oh, it was probably me then. I thought you weren't getting any.
There we go.
Okay, I'm going to pop it again because now I don't have display. And I'm assuming you don't have any right now either.
Correct.
And, okay, cool. So I was right the first time. Nope, I'm extended. Ironically, I had to cycle through the entire chart. Now do you have output? This is funny. I have to open up the GUI then. Oh no, it's claiming mirrored. You're not getting anything?
I got nothing.
Ooh, that's interesting.
At all.
It's interesting because it says, yeah, that. I will, because yeah, it's showing mirrored.
Now I got something.
Yeah, but we're down to secondary again. Let me mirror it. That's interesting. We've never had this problem before, and I plugged in here. You know.
There we go.
Did you change equipment? No. Okay, we're good. Awesome.
Technically, yes.
Cool. Okay. Hopefully, there's enough time. Everybody has the VM. Anyone still waiting? I know it's like two VMs, but it could take a year and a half to pull down. So. Today we're going over BSD. Does anybody know what BSD is? You could probably guess it has something to do with Linux because it's Linux, but it's not really. FreeBSD is a Unix operating system. So not exactly Linux. You've got kind of the same kernel underneath there somewhere. The reason we're going to be going over it and why it gets on session is because there's some differences between that and what we normally look at for normal Debian-based Linux operating systems. So it has a lot of different services, a lot of different tools plugged into it. A little bit of a different use case. You don't see people running FreeBSD as their main operating system for the most part. They choose to run Ubuntu because they make poor decisions. So normally what you're going to see FreeBSD on is things like Juniper or certain servers. It's very good at networking is what FreeBSD has. pfSense is based on FreeBSD as well. I think it actually uses, correct me if I'm wrong, Nick, do you know packet filter? I think that's literally what it uses underneath.
Which one? FreeBSD?
pfSense uses
PFSense, yeah.
uses packet filter underneath. So So the firewall on FreeBSD is literally used to run a router. So that's kind of where it's at for networking. It does that very well. Hopefully we have everyone's vApp open. We're going to be opening up freebsd-main because it's the main one. Log in here. We're going to log in as root. Same password as always. Great. Okay. First thing's going to be going over that, if you notice, we don't have apt. I know that's pretty scary. Instead of apt, we have package. Something funny about package is the first time you use package, it actually isn't installed. It has to bootstrap in, which is really annoying if you don't have internet or curl or wget or a GUI. So I had fun with that. A lot of the options are kind of the same. If package update's going to do exactly what you expect from apt, it's going to update the package list slowly. Oh, I didn't auth. Let's do that first. So there's a script, /auth.sh. Punch in your normal credentials. If you get an error, it's because you typed your credentials wrong. Yeah, that's exactly what you should get. You should get user authenticated. So back to that. Package update does what you'd expect. Package upgrade also does what you'd expect. Is going to attempt to upgrade the entire system, bring everything up to the newest version. That's not an issue in this case because I installed it fresh, so it's already updated all the way up. There's a couple other commands which are actually a lot nicer. We'll go over there, go those in just a second. Actually, I'll do package search. Guess what that one does? We're going to search through all the packages for whatever we type in. Tree. It's going to give us everything a tree. There's some nice auditing functionality, which I'll go over here in just a second. For the moment, I want to show where the repos are at. That way, when Red Team deletes your repos, you know where they're at. So if you didn't see that, it's going to be etc package freebsd.conf is going to be your base one. Anything else in that directory can be read as a repo. So if you have additional repos, they're just going to be sitting in that directory. In this case, we have the repo defined here. It can be defined in this file in multiple files, URL, the type, signature, where the keys are at, or so not keys, the fingerprints, and then whether or not we're going to enable it. So most of that's self-explanatory. Ideally, you shouldn't have to touch this. Unlike other distributions where there's a lot of repositories out there, correct me if I'm wrong, Nick, I don't think there's a lot of FreeBSD repos out there. You can set up your own, but for the most part, it's just the main ones. So actually going to installing a package, something sad about, and this is really the reason why why FreeBSD is not perhaps widely used, is that, oh, well, that's not going to do anything regardless. But if I actually try to install the failed-to-bound package, notice there's no failed-to-bound in the repos. Repos are not the biggest. They're going to have a lot of your core stuff. They're going to have your curl, your git, your nmap, but they're not going to have a lot of your extraneous services. Like Ubuntu, you can just type apt install, I don't know. For some of them, probably like WordPress, and you'll get a working WordPress installation. You're not going to get that on FreeBSD. You're going to have to compile from source. You're going to have to, I think you're honestly, in most cases, you're probably going to have to compile from source to get what you want in FreeBSD, if it's not a base tool. So to demonstrate some auditing, first we're going to install the tree package. So package install tree. It's going to do its updating. We're going to install it. It's going to ask us if we're sure we want to make decisions. We say yes. So now we have tree. If you don't know what tree does, just list everything in the directory. What's cooler? Etsy's cooler. Yeah, that's all it does. It'll show you a tree of your file path directory. It does have, as I said, FreeBSD and package has some nice auditing capabilities. So if we were to, let's figure out where the binary is at for tree. And then let's assume we're red team and we're going to turn this into a Trojan. So we're going to cat stuff to it. Now if we run package, make sure I get it right. Package check-h, and it's going to bring us a list of all the stuff that's been modified. All we're doing here is we're checking the files installed by the package, and we're checking them against essentially the sums we got along with the package. And that's going to tell us tree 1.7.0, so that's the package. There's a checksum mismatch for user local bin tree. So if you notice, if this was during a competition, they actually did install a Trojan version of Bash, for example, this would tell us, hey, there's something wrong with this checksum. Normally, I'm going to be honest, it'd be kind of odd to actually have a binary that be modified. So if it's in defense and security competition and it appears to be a binary that's modified, I'd say it's a fair chance that that's a Trojan of some kind. Now, we have some other files, which I'm actually not sure about this, so let's find out. Yeah. Because and this is something important to note, is that it's not going to catch everything. Let me check cron just quick here. So if you notice, I did it for .profile, and it didn't catch it because .profile isn't part of a package inherently. It's not a file we download. It's something that gets generated afterwards. So what I wanted to check here was I wanted to get cron tab, because that one actually might be part of a package. And let's shove some junk in here. And let's see if this is going to catch it. I'm not sure if this one's going to catch it. I'm guessing no as well. No, it's not. So that one doesn't catch it either. So in general, this is nice for auditing packages, but it's not going to catch a vast majority of stuff unless they're literally Trojan binaries. So if they do something to LS, you will be able to find it. If they do something to cron tabs or almost anything else, not going to be super helpful. Same thing goes for configs. I think it's going to be... Actually, let's try configs once, because it might catch it with configs as well. I'm guessing not, because it didn't catch anything else. Let's break SSH, shall we? Yeah. Yeah, no, it didn't catch it. So it's not going to catch pretty much anything except Trojan binaries. So, but that's there for your usage. Something a little bit nicer, which unfortunately isn't going to display very much, because I didn't want to take the time to install a malicious service. Let's package audit. So if you notice here, it was just like the vol and XML files up to date. It says 0 problems. What that command will actually do if you have vulnerable stuff installed, and once again, this is only installed packages, is it will actually tell you what the vulnerabilities associated with those packages are, which can be incredibly nice. Unfortunately, the only way you're going to actually get that is if they were able to install super old versions of packages, or if they're basically they have to get old packages in your system somehow. And they do have to install them the normal way. If they compile them from source, it's not going to show up. Probably not going to be super helpful, but conceivably, if you're going to regionals or something, it could be helpful depending on how much effort White Team took into it for preparing the system. So now we're just going to delete that package quick. We're going to delete tree that we installed. Yeah, going to remove that. And if you notice, it left the binary. So it left the binary because the checksum's different. This is decently normal behavior for most stuff. If we modified stuff, so it's not the same as it was before, it'll leave it. So let's just RM that as well. Not a big deal. But just keep in mind that if you ever remove a package and you see that, like netcat or something, then maybe you know now. Okay. So that's most I want to cover just for that. Let's get a connection open. And this is actually here. Can I do... I don't know if this is going to work or not. Okay. We're going to find out. Okay, it did work. So, something else to... It's funny. Okay, no, it's still there. Oh, wait. I thought that didn't exist on here. That's funny. Yeah, that's funny. Okay, we actually do have netstat. Nick, I've been lied to. I thought we only had sockstat. Oh well, sockstat's nice as well. So we actually do have netstat apparently.
Sockstat looks nicer. You can actually see like problems.
It does look better. So in general, we actually, I could have sworn we didn't. I must have installed it by accident, ironically, because I was trying to install it to test it was there. So normally I thought you don't have netstat. Netstat also isn't probably going to come default installed. It may not. Sockstat is the better alternative on FreeBSD because, you know, they like networking, so they have a really nice utility to be able to see your network connections out. So the default Sockstat is going to give you something like this. We have users over here, which is nice. We have our commands. In this case, what we care about is the SSH connection using TCP over IPv4 to with the local address being whatever the ephemeral port is to the destination of that other box I have on there, the FreeBSD test. We have some other options with Sockstat as well. If we do -C, it should only show the connected. So this was something I found interesting as well, is that if you notice, it shows our one connected connection of SSH, and then it shows a lot of garbage. I don't know what that is supposed to mean. Do you know what that's supposed to mean, Nick?
Which ones?
The question mark ones.
I think those are Unix sockets.
Yeah, that would make sense, but it should be showing the path then, right? Huh, odd. So I don't know. I guess now if you know your question marks and sock stat, that's normal behavior. So that's not red team doing something fishy. It's just FreeBSD being weird. So something nice to know, that sometimes the operating system does things and we don't necessarily know why. But I'm sure somebody knows down the line. -L will show what it considers to be internet sockets. So it's not going to show localhost stuff if you do the -L. Lowercase l is just going to show listening stuff. So nothing that's going out. If you notice, we lost that SSH connection. That's no longer there because it's outbound. That's not inbound. So for server stuff, you're probably going to want to do something like that to start. That's going to only show. We don't care about localhost in general, and we only. If you're only looking for listening servers, that's the way to go. Of course, outbound in competitions is just as scary. We also have some other options as well. -lowercase p for ports is actually a little nice, which is funny because it will always show the Unix sockets when you do the port. I don't know why. It will. So the Unix sockets will be there, but then it narrows it down to stuff that's using port 22 in some way, shape, or form, such as the server running right here. And I can't mouse over it, but about the 6th or 7th down, we have our SSHD server, and then number 1's, of course, the outbound SSH connection. And then we can also use a -P, and we can do TCP. So -P means we can specify the protocol. This is probably only useful if you're looking for something weird. Thankfully, it does narrow it down and gets rid of all these Unix sockets. So if we wanted to just get rid of all the Unix sockets, I don't know if we can actually do this. Let's see if that works. Nope, it won't do it. So if you were just concerned about TCP, we could do probably something like, yeah, that'd probably be the way to go. It's probably the best command, and then same thing goes for UDP. That'll get rid of all the Unix sockets that in general I don't think we care about for the most part. And just gets us down to all the UDP and TCP connections. If you also notice, it'll show TCP4 and TCP6. So that, of course, means we're using IPv6 versus IPv4. That's always something you get to worry about, is the chance that IPv6 is going to slip anywhere, because it's a protocol that, it's a protocol that exists that makes firewalling a little bit more annoying. Okay. So that was all the repo stuff. That was all that. Let's go over the init system. Normally, when we're using other systems, we get a couple of different init systems. They kind of manage the services for the system. The common ones you're going to see is if they're using etc init.d. They're probably using, and once again, correct me if I'm wrong here, sys5 init is the most common one I see there. Upstart is something you'll see on Ubuntu only, as far as I'm aware, because Ubuntu always needs to be special. So they'll do weird things. And then you'll see systemd, which is the essentially newest and now most popular, I believe, as far as newer distributions go, a NIT system. FreeBSD also feels the need to be special. We don't use any of those. We use, I believe it's literally called FreeBSD init. But it acts very much like some of the other ones. We have, all of our service files are going to be in etcrc.d. And if you guys wanted to mess with a service, you can either do it the nice way or you can do it like this, which is you go to the directory and you can just query stuff like you do normally as if you were using service. Or you can just use service, because that's what we have. And that's what that really boils down to, is we use service. Use service. Don't use systemctl. It won't work. It doesn't exist on the system. So keep that in mind. As always, you're going to have whatever options provided to you by the service. So in this case, oh no, it's not giving me the options. Huh, interesting. Let me try doing it. Yeah, we go. Okay, that's interesting how it gives me usage options depending on what I do. So just notice for that one alone, we actually have quite a few options, which I wouldn't say we normally get. As always, the services themselves can determine what they want to give you. So if there actually might be some useful ones in here, for example, like keygen. I honestly don't know what that does, but that might be helpful and it's not going to be coming. You won't be able to see the usage on a normal service call, as far as I'm aware. So that's most of what you have for initd. The one other kind of cool thing it does, which we're going to get into here in a second anyway, is, what is it called now? It's conf. Okay, etcrc.conf. So FreeBSD actually did something right, and that's they decided there might be a good idea to have a centralized configuration file for some things. So we don't have to have a million ones strewed around. We still have a million ones strewed around, but now we have one more. It does give us the option to configure some stuff in here. If you notice, we have the host name configured in here. We have the network interfaces configured in here. We have SSH enabled in here. Obviously, SSH has its own configuration file, but in here we enable it. And we have whatever dump dev is, I guess crash dumps, which is fair. So if we crash, that'll get saved too. So as I said, this is an okay idea. I think it's probably pretty nice until you have like a million services, and then this whole entire file is just flooded through for like 13 different services configuration options. But for the moment, it's not too bad. So we actually do have to edit stuff. So I'll show that path one more time if you guys forgot it. etcrc.conf, because we're going to be getting into firewalling. FreeBSD does not have IP tables. This is probably the core thing to get out of this talk and nothing else, that FreeBSD does not have IP tables. If you type IP tables, nothing will happen. So if you know how to use IP tables, that's good, but it won't work on this particular system. We actually had 3 options for FreeBSD for choosing firewalls. There's, I believe there's IPF, there's PF stands for packet filter, which is what we'll be using, and I think there's UFW. One of those 2, I don't remember which one of the other 2, is also used in Solaris. So that's why it exists. It's because it also exists in Solaris. I don't know why that would be a good reason to have it on FreeBSD, but apparently it is. The other one, I don't actually know of any reason for it to exist besides the fact that it does. So for the most part, packet filter is what I decided on. It's gonna be. It's honestly, it's more or less the base one. Well, not obviously, but some of them, none of the firewalls are enabled by default. But packet filter is what I found have the best syntax, and to be more or less the default one. So, but to even get the firewall working at all, we do have to enable stuff. So that's the fun stuff. Can I have it back, please? Okay. The iLab likes refreshing my things every 3 seconds. So we have to type pf enable. I'll let you figure out what that one does. We have to give it pf rules. So this is going to specify where the rule file is. Unlike IP tables, or at least unlike IP tables, unless you install that one service, you actually have a file to work with that it'll load from on boot. You don't have to restore or output to a file. You just edit the file, you type a command, and it'll load them. And then it should also load them back on boot as well. Other optional commands are going to be that we can enable the logging for firewall, which is good for troubleshooting and for seeing how many packets you dropped from red team. So that's the enable, and then once again, this is the file that we're going to put it in. We're just going to put it in pf log, in var log. You have options here. You can pass them some additional flags to start up. We don't care about any of that. So we're just going to stop it there. So now we have options to start doing some stuff. We're going to write a really basic one first. So we go to the same file we put in there. So for whatever reason you put a different file besides etcpfcomp, you're going to edit that one. And then we're going to write the most basic firewall you can write. You are now 100% secure. Block in all. Which means you won't ever send, well, yeah, you cannot receive any traffic now. The reason I did that is because we have to make the file to even start the service. So if we actually try to start the service now, my picture off. It's going to give us a name in pf, and then we're going to start pf log as well. Cool. Okay. Also, if I'm going too fast, which I'm almost certainly am, please let me know. So we start the service. PF has a little CTL tool, which is kind of nice. It's kind of nice and also terrible because it doesn't have a status as far as I'm aware. If we do pf dash, oh no, it actually does tell us. Okay, so it was already enabled, but we can also use this to enable. Dash E will enable it, which as I said, it's already telling us it's enabled. Use dash D, we disable it, which is what red team's going to do over and over again. And then we have dash F. So F will load the rules from the file. So, and that's kind of the whole thing here is that PF has no way to modify the rules that are currently in memory. Your only option is to modify the file or modify several files and to load them all in. So there isn't just a bunch of rules sitting in memory. It's either the firewall's on, the firewall's off, and if the firewall's on, we're pretty much going to load from that file. We don't have any other options. So no matter what, we're loading from a file somewhere. So if we do pfctl-f, we need to specify the file like that. So that would load the rules in again from the file. It doesn't do anything because they're already loaded in. We also have a couple more options. If we do dash V, it's going to do it verbosely. So it's going to tell us a lot of, well, at least a little bit more information than we currently knew. Currently, it's yelling about no ALTQ supporting the kernel. I already forgot what that was. I remember looking at it, and I don't remember what it was. It was I don't think it was QoS stuff. That's functionality. You don't need it, is what it boils down to. But keep in mind, you're going to get this error message every time. And then it's going to give us a nice one rule that we actually put in the firewall. Occasionally, your rules will look different because it does some additional parsing. Later on, you'll see that they like to shove keep state after a lot of stuff because keeping the state's actually relatively nice. And then the one other command you should know is the dash n flag. So if we shove the dash n flag, it will not load the rules. It will interpret them, and that's it. The reason why this is good is because this allows us to check our firewall rules before we apply them to make sure we don't have syntax errors. So if we use dash n, we're looking at the rules. The rules are being displayed to us, but they are not being loaded into the firewall. So that's the option. I'll do that. It'll shove it back at us again, and then not do anything. So now we're actually going to write firewall rules down. So just to verify that's working, and that actually, I'm not sure if it is working, make sure CTL. Great. So make sure we're enabled. Let's pop back over here to tester and log in. Come on. Okay. So if we try pinging. Okay, so we're currently dropping packets. So if I Control-C this now here, we're going to see 100% packet loss. So we're dropping everything going into that box right now. So that one firewall rule is in fact working. So let's start working on that one. So let's actually edit some stuff. So this is, let's write the next one and then I'll kind of give you an idea of what's going on here. Some of the reasons why I actually think PF is almost nicer to work with IP tables is that they have essentially list support and variable support as well. So using those, you might be able to spend an extra 15 seconds writing a little bit more of a readable firewall. We're going to define two variables up here at the top. We're going to define internal, and that's going to equal our emo0 interface. And then we're going to define our external, and that's going to equal, oh, no, those are backwards. My bad. Yep, those are backwards. Thanks, tester. I really wanted to talk to you again. Okay, so those actually should be right now. Normally, of course, you're not going to have an internal interface and external interface. You're probably only going to have one. The way I set up the app is that we have a connection to vCloud. So that's where we're going to send all our outbound traffic. And then we have our internal connection, and that's where we're going to have all of our connection between, in this case, just main and tester, but your actual network. So most of this would all be consolidated down to one interface instead of having the two interfaces. Any questions on that? And how that's different than normal? Okay. So currently we have one rule and it says block and all. So that you have two actions that you're normally going to work with for basic stuff. It's going to be either block or it's going to be pass. So block means we're blocking and dropping everything. In means we're doing an inbound versus outbound, and then all means everything. We have some variations of what we can do here. So here's an example here. If we do pass in, so this is talking about inbound traffic right now, and then let's do the internal. So this, once again, this is where it shines a little bit, is that we can write scripts out like this, and then we can just set the interface name at the very top. So we don't have to worry about what the interface name is. We don't have to do any find and replace. We can just do it. So proto TCP. That means we're defining the protocol as the TCP protocol. So normally you could, if you wanted to, you could just put all there, I think. In this case, we're going to do from any to any to give you the idea of what's actually going on there. So that means currently any TCP traffic, as long as it's coming inbound from any IP address, from any source IP to any destination IP. Yeah. Oh, no, we're actually not doing any to end there, my bad. So this is going to be, that's our external address right now. Or not our external, that's our internal address, but it's the IP of the interface. So what that one is doing right now, so we're allowing inbound protocol TCP, anything on the TCP protocol from any IP address to 192.168.1.10. That's going to be the IP address of our interface. And then we're specifying port 22. You cannot specify port unless you have the protocol right. So if you do not specify proto TCP, I do not believe you can specify the port because certain protocols do not have ports like ICMP. So keep that in mind, unless I'm wrong about that. I don't think I am. So we're going to do one more rule here. So let's talking about ICMP. Let's make a rule for that. Okay. So currently, we're also allowing ICMP in from anywhere. So let's check this quick here. Well, looks good. We're allowing in. We're blocking inbound, which something else to note is we're only blocking inbound at the moment. So if we pop back over here. Oop, did it wrong. Oh, yeah. Anyone know what I forgot to do? Like many things, like exit the file or load the rules. Yeah. So obviously we have to save it to disk, and then we do have to load. Yeah, that might be a good idea. Like actually apply the firewall rules, and then that's how we're going to load them. So if you notice I didn't get an error, that means I'm good to go for syntax-wise. So. Okay, awesome. Now we got ping back. So. Keep in mind if. So let's just check this here. Now we're going to try pinging the other host. Yeah, so that was always good. We're always able to do that, and I'm going to show you why that works. So we can currently ping out, and we can ping in. The reason why we can do that is because if you notice, I only did block in all. You have to specify block out all. That's also something I probably should have mentioned before. PF uses sequential rules. So we start looking at rules. We find the rules that match. In this case, it's going to be the block in all rule. That's going to match first. And then, assuming we're assuming we're SSH outbound, we're going to see the second rule. Now the second rule is going to match, and then we're going to hit the end. So PF runs on a last match basis. This is different than IP tables. As a reminder, IP tables runs on a first match basis. So for IP tables, the first rule that hits it, we keep. In PF, the last rule that hits it, we keep. There is an exception. If you specify the quick keyword, once it hits that one rule, it'll automatically jump away like normal. So if you wanted to write like an extra word in every single line, you could probably try to implement some sort of IP tables functionality. It's not worth it. Just do it the way they intended you to. So for example, if we actually wanted to block, somebody should really fix the refreshing thing someday. You can totally do it. Just write a Tamper Monkey script. It's totally possible. What?
I think I already did the refresh.
Does it work though?
Yeah.
Oh.
No, not the refresh. I fixed the stealing focus one.
Oh, the stealing focus though. Will it still jump up in front of your screen though?
Yeah.
Oh. Okay. Give me that afterwards. So if we're trying to ping out here again, previously where we were able to because we weren't blocking that. Oh no, I'm getting bytes out. Yeah, I wonder why I'm getting bytes out again. Yeah. So, as a reminder, this is probably something you're going to forget now. You have to apply the firewall rules. You write them in the file, they don't automatically change unless you reboot. So you have to run that pfctl-f to reapply the rules. So keep that in mind. Actually, that's going to be really annoying because now I think about it, Red Team is just going to modify the rules and then write them back to disk as they were before. So that's actually, Red Team, you should be listening to that one. That's actually really annoying because we can't tell what the rules are currently in memory. We just have to reapply them. So that's annoying now I think about that. Yeah, that's really terrible. I wonder why that functionality doesn't exist. Okay, so we're being blocked now. We can't send outbound because we blocked all the traffic there. So let's actually like allow that outbound. Okay, so as kind of the normal thing, now we're going to do pass because we want to let it out. This is still the internal interface. We're using ICMP, and we can still do from any to any. It's not a big deal. And that's the thing they do. They will always. I don't think you actually have to specify the source address if you just do all. But in general, you're going to end up specifying the source and destination even when it doesn't matter. We're doing ICMP outbound. There's nothing that can really be done. Well, that's not true. I'm sure you could do some data exfil with ICMP. It'd be a lot of effort. I encourage Chris to go do that. Write your command and control only using ping packets. That might be a little bit painful. But that's something to do. So you can, and of course, you can modify it down. In this case, because we have source and destination, one is almost going to always be any, because we normally don't care about the interface. If it's coming in, we don't really necessarily care what interface it's hitting, because normally we're only going to have one interface that can actually hit. And if we're sending, we normally only care about the destination. We don't care what interface we're sending from, almost certainly. The only exception is if you actually had a box that had 2 connections, and then you might care. But that's really the only case when it's actually going to matter. So currently we're doing pass out, internal, yep, so TCP protocol from any to any. Okay, cool. Now let's actually remember to apply it. Okay. And let's try pinging one more time. Okay. Does anybody know what like appears to be missing that we normally have to have in IP tables for this to work? Any guesses on like, so we have rules in there, but the one rule we normally have to have in IP tables to make all this work is the state. Because in general, if we're not allowing state, even though we're allowing, and actually I think we're actually allowing ICP by both ways now, which kind of takes away from that. But if we didn't, I'm just going to delete this line because I honestly don't remember what the comments are for PF. So let's delete that. So now we're not allowing ICMP back, and you know, got to remember to apply those rules. It's almost like IP tables had it right for just automatically having them apply. Okay, so if you notice, we're still getting bytes back over ICMP, even though technically we're not allowing that. So let's look about why that actually is if we do pfctl. So same thing that we did before, but we do dash verbose. Yeah, so if you notice there's some extra stuff that's on there that we didn't necessarily add. We have keep state on that now. That's something that's automatically going to get applied on some of your PF rules, which explains why certain things are occurring. Yeah, if you notice, it's on both of our rules. It's on both on the ICMP rule and on the SSH rule. So you don't actually have to put that in there. And actually, you can specify keep state in there directly, and it will not throw a syntax error, but it automatically is appending that. I think it's appending that because of the protocol type. I'm not for sure, though. Anyone wants to look up later why it likes to append keep state on everything, that'd be a good idea. But because it appends keep state, that means we don't have to write an additional 2 rules, one to allow stateful stuff inbound and one to allow stateful stuff outbound. So that's kind of nice. So let's do a couple more rules, and then we're just going to call it quits for tonight. So let's try to allow internet, or let's try to get to Google. So we need to pass out on external this time. Yep. So we want to do TCP protocol from any to any. And then, so this is where I would say this really shines, is that we can specify lists. So normally this would take either 2 IP tables rules, or we'd have to use, I don't remember what they call it, like a macro or something else for IP tables to get the same functionality. Here we can just specify the list and it works. We're also going to need DNS. Oh well. Oh no, caps lock got turned on. I also don't know if that function, if that's actually works or not. Okay, and we can do the same thing here as well. which is, as I said, really nice that we can just shuffle this where we want. Yep, that looks, let me just double check I did that right. Yep, didn't throw me an error. So, and just as a reminder, very occasionally, UDP will use TCP, or not, okay, that made no sense. DNS will use TCP, very occasionally. I don't remember why. I think it's because at some point the amount of data we have to transmit over DNS is too large to be able to do it properly with UDP anymore. So. But now if we apply that, and I didn't mess it up, we should be able to curl. Yeah, we can curl google.com, and it's going to yell at us and tell us to go use SSL, but that's fine. So that's all I got for tonight. Anybody have any questions on that? Almost certainly not. Okay. Good to go. Hand it off to Brian.
It says I'm airing it.
Huh? Oh, you did it? Chris, it's possible.
If you grab a wire sharp, you can get it. If you use PCR, you grab the.
Oh, that doesn't count.
Yeah. Let me try this. I have some VMs open. Do that. So I'm actually configuring the screen.
So it's acting like there's another display.
Yeah.
Might have to bypass the stream.
It is impossible. You have to use one of the variations to do it. Yep. That was a good run.
Oh, there we go.
Some things. Need to exploit my box first to make this a good demo. Don't do that. We don't need to firewall, right? It's not good. We don't need to firewall. one should work. Maybe. That should be good enough for now, at least. I wanted more, but so let me do one more thing, just to really show off how good this tool is. What's it called? Okay, so there's a lot of interpreter shells open on this machine, and a command shell and other things. So I'm going to demo something a little bit better than Task Manager, which is okay, because it gives you a description and an image name and what user it's running as. So clearly you can see there's some weird stuff running, but there's an even better way of automatically analyzing some processes and trying to figure out whether or not they're good or bad. So many, many years ago, I had stumbled upon this tool called KillSwitch. It's made by Komodo. They make an antivirus. It's actually called Komodo Cleaning Essentials because it's a package of tools to clean a system after it's been infected by malware, as the red team does at CCDC. Komodo Cleaning Essentials includes a on-demand antivirus, KillSwitch, auto runs, hijack this, which does a lot of different things. So click on the second link in Google, the help.komodo.com link. It takes you to this download page, which is just a direct download, real easy to use. So download the zip. My VM crashed. This is great. That means all my sessions are gone. But I ran persistence. There we go. Of course it's going to update too. Thanks, Windows. Live demos. Let's do something real quick here. Okay. Let's try running this again. That was my problem, I think. Yeah. Please work. Just so we have multiple shells and multiple things going on. Of course, nothing ever works in a demo, so. So I have a few sessions. Okay. So as I was trying earlier, actually I already downloaded it. No, I didn't. I lied. So I just copied the folder inside of it to extract it. So Komodo Cleaning Essentials is made up of, you can see it, CCE, Komodo Cleaning Essentials. This is their like antivirus by Komodo, so it downloads their virus definitions and then just scans your system for viruses. Auto runs, similar to in the suite of tools by Microsoft, their sysinternals, thank you, where they include auto runs and a their process view, process list program, which in here is called Kill Switch. And Kill Switch is really cool because when we run it and you agree to their terms of service, it's going to load here. And
antivirus, does it stay like security, Microsoft Security Essentials, how it runs the whole time it does active
no.
So it's just one-time scans.
Right. It's just a one-time scanner. Yeah, Komodo Clean Essentials is only scans on demand. It doesn't do any real-time monitoring. So Komodo Kill Switch is really cool. You get this fancy interface, lots of information thrown at you. On the left-hand side there is a list of the processes and sub-processes running underneath each image name. So down here, I'm logged in as a user. It's running Explorer, and then I'm running Kill Switch underneath that. But what it does automatically is it automatically analyzes all the processes running in your system. It scans the exe and figures out whether or not it'd be trusted or untrusted by Komodo. If it's signed by Microsoft, it's automatically trusted. And then it just shows you all these other ones that are untrusted or unknown. It's never seen that file before. So as you can see here, it's already identified these binaries running in the memory, running as the system user, because I exploited the box. These are actually the interpreter sessions I have, the ones in gray. So it's really easy to just go in here and be like, oh wait, I'm infected. It already did all the hard work for me. I have to go just kill those processes. So to do that, all you have to do is right click and then kill process. Or you can click on the process hierarchy above it and just do a kill process tree. And if it doesn't kill it right away, you can do a forced termination, which tries even harder to kill it. I can just go ahead and do that. And if I pop up back over here to Kali, it says Mature Session 8 closed, reason died. So now we're killing the shells on the system. So this is really good for just automatically analyzing stuff running in memory. If it's a separate binary, it will just detect it as being unknown or untrusted. You can just go ahead and kill it right away. Doesn't replace a real antivirus, but even if something's not detected by the antivirus, this will still tell you it's like an untrusted process running in memory. So down here you have PowerShell running, and then CMD, and then a interpreter session underneath that. So one thing this doesn't detect is like something is just if the interpreter session is just running inside a PowerShell, it will detect PowerShell's running, and it will detect it as a trusted process. So there's one caveat to this, is that it won't show you interpreter sessions if they're injected inside another trusted process, or like SVC host or something else like that. But these other ones stand alone. It just pops out right away that you can go and kill them. The second part to this that's automatically integrated in the whole application is this other tab called Network, which just shows you all of the active TCP and UDP connections on your system for each process. So let's say I'm looking at that PowerShell process, and I see it has an established connection to a unknown IP address that it shouldn't be. So I can either go and kill the process. So I can go to the process, it automatically highlights it. So I just find it, I can right click and kill the process. So even if it's a trusted process running, I can go to the network tab and see that interpreter or a command shell is still calling back, and I can go to figure out exactly what process is causing that. But let's say it's running in something really, really critical, like WinInit. It has to be running for your system to run, otherwise you just crash Windows by killing it. What you can do, you just come over here, you can actually close the connection. So in this case, it we just restarted that connection because my interpreter was still running. But for some cases, just closing the connection is good enough, and the process will just disappear. So even if you don't want to kill the process, you can still close the connection. And so this is really nice because it does stuff like auto name resolving through DNS and other things. It's all integrated in one application. It automatically scans your memory for untrusted processes. And the whole network tab will allow you to close those connections is really nice. So there's a few advantages over just regular sysinternals tools. And then if you don't really want to know, if you only want to know what the untrusted processes are, you can just filter. You can just view show untrusted only. And then bam, I can just go and kill all of these because I don't want them running. They're untrusted or unknown. Alternatively, you can just do hide process assigned by Microsoft. So then it'll filter everything non-Microsoft on the system running. So, and then from within Kill Switch, it can launch these other programs like auto runs. Let's see here. So auto runs is exactly the same thing as Microsoft Sysinternal's auto runs does, except this also will go through and scan whatever file is pointing from that in the registry or scheduled tasks, and it determine if that file would be trusted or untrusted. So, and you can also filter. So I'm going to go hide trusted entries, and I can see that there's 2 services installed here with binaries running in C Windows temp that have an unknown rating. So I don't want those services running on my system. So I can just come over here and delete the entry, and it's just gone. So it's a really fast way of killing that persistence through services, scheduled tasks, anything that may be running. Again, you can do this all through Sysinternal Suite, but this does a lot of automated scanning of those binaries for you to see what's untrusted. There's one other feature that Kill Switch has that is active. So while you have Kill Switch running, I'm going to try and be really fast with this. It shows new services created in the bottom right-hand corner down here. I know it's hard to read, but it actually tells you the name of the services as it's created. So if somebody's creating services or running PSExec against your system, Kill Switch will alert you that that service was created. And you should probably check out why someone's hacking you. So another feature Kill Switch has while it's running. But yeah. And then I use Kill Switch on every Windows system. I don't believe it works for XP anymore, but Vista through 10, it works. I've used it a lot. And I have it constantly running as soon as I can, just so it can alert me on services and I can see other things running in my process list on my system. And then while that's running, I always go and download Security Essentials. So on clients like Windows 7, Windows 8, Windows 10, or not Windows 10, but Windows 7, Windows 8, you have a lot freer choices of what antivirus you want to put on the system to catch basic shells like Interpreter. So there's a lot of really good ones out there. Avast, Kaspersky, ESET, not 32, is a personal favorite of mine. But you know, a lot of choices there. So, but on Windows servers, 2008, 2008 R2, 2012, most of those will not install because they're made for client systems, not server systems. And they just have code in there to say don't install it on servers. So that's why I use Microsoft Security Essentials. So Microsoft Security Essentials was created many, many years ago by Microsoft as they wanted their own antivirus for consumers to use. They first came out with Windows Defender as part of Windows 7, but it only detected spyware. It basically detected nothing, and everyone hated it because it did nothing. So they came out with Security Essentials, which was much more complete, but you had to download and install it. So during this whole time, they released Windows 8, never included anything. And as most of you know, in Windows 10, they actually included what they call Windows Defender. Windows Defender is Security Essentials renamed and much better. Windows Defender is tightly integrated in the system in Windows 10 and does a really good job of detecting stuff like Interpreter just by default. It does some automatically uploading files to Microsoft servers to sandbox them and figure out what they do, what they do on the system, how they modify it, and whether or not it should be blocked or not. So it does a really good job by default. So Security Essentials will install on all client machines from XP to 8. You don't need it on 10 because it's already built in. And then it'll also install on Server 2003 and Server 2008 and 2008 R2. It should install in 2012 as well, but we had some problems with it last time.
Yeah, I had to run it. If you right-click it and you can run this compatibility on Windows 7, you have to open it in PowerShell and do like do not
Oh, okay.
So then it'll just run anyways.
Gotcha. So you can install it on Windows 8, or 2012, excuse me. It takes a little bit more effort, but you can get it installed. My Internet Explorer is just not responding.
It's not a browser.
We'll do this.
You can install security essentials on the Mac.
Drag and drop is pretty cool. So I'm just going to run Security Essentials installer as administrator, hit next, I agree. Doesn't really matter here, you're only going to run it for a few hours. Turn on Windows Firewall, turn on automatic sample submission so it sandboxes those in the cloud, and it's going to start installing. Now, it's pretty fast to install. It automatically updates and scans by default when you hit finish. So Komodo also alerted us that there was a new service installed, Security Essentials. So while this might not be the most advanced because it doesn't do a lot of advanced memory detection techniques or it doesn't have a built-in firewall, advanced firewall, it's really good baseline antivirus to get installed in the system since it works on everything and does detect all those basic shells. So QuickScan's running. I'm surprised it hasn't detected anything yet. I wonder what triggers that. Let's run this again. Detected threats are being cleaned. So after I just added persistence to this box, it detected something. It's still working, figuring out. Still cleaning the file or deleting it, actually quarantining it, but as soon as it's finished, it's going to quarantine it. It's going to show up in this detected item, so you can look at what paths it was being launched in or run as, and that's that. So Kill Switch and Security Essentials are my two go-to things for basic antivirus and some defensive process monitoring and network monitoring. After I have the firewall configured, of course. But yeah. Any questions?
Did you
Comments?
say that Security Essentials was already built into Windows 10?
Yes, Security Essentials is built into Windows 10. They label it as Windows Defender. So you should make sure Windows Defender is enabled if you have a Windows 10 system. And they're constantly updating Windows Defender in Windows 10 and Server 2016. Also, Server 2016 has it, which is really nice. That's why we won't get it for any mocks. Because it's just too easy. But the Server 2019 will have it as well. In the latest update, feature update for Windows 10, they included a ransomware module, so you can tell it to watch folders and have it alert you on any files changed in those folders, which is really neat. By default in Windows, so good for us blue teamers. Red teamers probably don't like that as much. Yeah. Any other questions? Comments? Quandaries? Cool, that's all I have.